Welcome to 2.7. Today we're going to be expanding on the rules that we've covered in the past. I think it was in 2.3, I believe, or 2.4, where we covered special products with polynomials. And so we have these rules here. And the thing about these rules here is, again, now we're going to try to go ahead and factor. The goal was different in the black section, but the idea is revisit these rules and see if we can find a trend. And then we have, again, the rule over there, and then we have some examples over there. And so we're going to try to see if we can use these rules to go and see if we can find if trinomials are perfect square trinomials. For the end goal is to factor in these special products. So let's go ahead and see how we do. So determine whether each trinomial is a perfect square. So this right here, this applies to this rule here. We have a squared plus 2ab plus b squared equals, the rule says it equals a plus b squared. We're going to see if this is true. Now, in order for us, again, and this, the end product as well is going to be a plus b, so again, these are the factors, right? These are the factors of this trinomial if it follows the rule. And now to go ahead and see if it follows the rule, we must first identify, hey, what's my a value, and then what's my b value. My a value in this case is going to be, I'm going to say 9x. And then my b value is going to be 5. Okay? And again, think about plugging it over here. 5 over here, 9 there. And so let's go ahead and see if this works. Again, this is my a squared plus 2. Remember, we do this in class, and this is my video. And then just you plug it in. You're plugging in stuff. You're plugging in your a's and your b's. So my a is going to be 9x. Again, ab, that rule over there. So 9x. B is going to be 5. And then over here, okay, and then over here is going to be my b, so it's going to be 5 squared. We're going to say, hey, is this equivalent to that? Is it equivalent? Well, let's go ahead and evaluate. We have 81x squared. So that matches so far so good. 9 times 2 is 18. 18 times 5 is 90. So that matches up. And then 5 squared is going to be 25. So this right here, we can say that this is a perfect trinomial. And if it is a perfect trinomial, right away we can say that the answer here is going to be 9x plus 5 squared. Okay, that's one version. So we can say, hey, those are the factors. If you want to expand, you would say, well, guess what? This also equals 9x plus 5. Okay, and so those are the factors. You can do this the box method, although I think the box method will take a long time just because we have a large a value. And so this is another way of us factoring trinomials that have large a values. And so this is the end goal here. So again, factoring special products using our rule. Let's try another one. Another one we're going to try here is we're going to say, again, we're going to say that, hey, this, we're going to see if this rule applies to my current, trinomial. And so if this is the case, again, we're going to say a plus b squared. Okay. Let's go ahead and find my a. My a is going to be x, or 1x. And my b value is going to be, in this case, it's going to be 2. Okay? Because x is a perfect square. Again, perfect square. X is a perfect square of x squared, and then 2 is a perfect square of 4. And let's plug it in here and see if that makes sense. So, remember before, we just were practicing replacing my a's and my b's. I said my a is going to be x, and then my a is going to be x again. My b is going to be 2. My b is going to be 2 there, and I can say, well, let's go ahead and evaluate. 2x squared plus 4x plus 4, and so this matches my original right there. It matches my original, and we can say, guess what? This is a perfect trinomial. It follows this rule here, just because x squared is a perfect square, and 4 is a perfect square. And what do I mean by perfect squares? I mean x times x is x squared. What I mean by 4 is a perfect square, I mean that 2 times 2 is a perfect square. And so that's why I can go ahead and say my a is x and my b is 2, because they are perfect squares. So if this follows the rule here, then we can say, well, the answer, right, to my factored form, we're going to follow the rule, is going to be my a squared plus b squared. So what's my a? It's going to be x. What's my b? 2. And so that's my answer. And again, if you want to see it in expanded form is going to be x plus 2, and then x plus 2. Okay? So again, another perfect trinomial. Let's keep going. We're going to go ahead and use this rule for this one. We're going to do one more before we move on. We're going to use the rule of a squared minus 2ab plus b squared. And this is going to give us the answer of a minus b squared. So it's no longer plus, it's minus, because we had a minus. So the only thing that's changing is this minus. Everything else remains the same. We know my a value is 1 and my b value is 7. And again, even though my a1 over here is going to be, we can say, well, we know we have a 1 there, right? But over here, say, well, my b is supposed to be 7, right? But again, 7 squared is 49. So all we're doing is we're plugging stuff in here to see if this makes sense. We're saying, hey, plugging stuff in there, 2ab there, and seeing if this is true. So I'm going to plug in my, and really this should be 1x right there. That should be 1x. So we're going to say, well, this is going to be 1x. Over here, we're going to say, well, again, this is going to be just 1x or x. And we're going to say my b value is going to be 7, and again, 7 over here. And then we evaluate, we get x squared minus 14x, and then plus 49. So, hey, guess what? This matches my original trinomial. So I can say that, hey, this is going to be, a minus b squared. So my a is going to be x minus b is 7 squared. And again, if you want to expand it, see how it looks like, you say x minus 7, and these are my factors. You can always double check if you're doing it right. If you can go ahead and refoil, and it should give you the original polynomial. All right, let's move on to a different skill here. We're going to go to the last part here. We have difference of two squares. And if we have difference of two squares, we can right away factor. These are our factors of difference of two squares. We have a real example over here. X squared minus 9. We can rewrite it as x plus 3, x minus 3. So recognizing and factoring the difference of two squares, we're going to go ahead and factor here. So here we can say, factor out the difference of squares. Well, this would be the difference of two squares. Is 3 a perfect square? The answer is no. 9, no. So we're going to see that this right here this is not a perfect square because, as you can see, we can break up the 9 into individual components, and you can multiply 3 times 3 is 9, q squared times 2 squared is 4. However, the 3p, we can't break it up like we broke up the 9. The only thing that's a perfect square here would be your p. It'd be p times p. So you could break up p and p to get p squared, but you can't break up 3 where it's going to give you like a perfect square. Right? So this would be, guess what? No, this is not a factorable binomial. This is going to be a factorable because we can say that 100 is a perfect square. We can say that this is going to be 10 squared and x squared minus 2 squared and then y squared, which can be said as, guess what, 10x squared minus 2y squared. So guess what? The difference of two squares, two perfect squares. So the rule says that we can rewrite this or that it expands to that notation right there. Now, we can use this rule to go ahead and find the factors. So, according to this rule, again, this is just going to be equal to, well, yeah, let's go to expand. So let's go ahead and we can say, well, this is going to be 10x minus 2y, and then 10x plus 2y. And you'll find that if you go ahead and hey, say these are my factors, if you go ahead and FOIL the factors, that you would get the original answer. You're following the difference of square rule. Let's do one more over here. We're going to use this rule over here. We're going to use the same rule. We're going to say, hey, if we have a difference of squares, that we can get these these factors. And again, it doesn't matter which order you write them, as long as you have 1 plus, 1 minus. It doesn't matter. So I'm just going to go ahead and erase this and just leave 1 up there for less confusion. So now we're going to say, well, how does this look like now? Well, is x to the 4th a perfect square? The answer is yes, because x to the 4th can be written as square. And then this guy over here can be written as 5y, and we're going to say, so I can say, hey, guess what? We do have a perfect square here, and we do have a perfect square over here, okay? So then we can say, well, we can rewrite it over here. And again, I put y to the 3rd because y to the 3rd times y to the 3rd equals y to the 6th. So then I'm going to write it this way, x squared minus 5y, x squared plus 5y. And those are my factors. That's my answer. Following the difference of squares rule. All right, let's move on.